now we'll look at simplifying radical expressions. And when we ask, we're generally going to ask you to write your answer in exact simplified radical form. So if it's not a perfect square or a perfect cube, and you don't just get a nice whole number answer, then, or integer answer, then we're going to look for an exact simplified radical form. And so the only way to do that is to do this by hand. I mean, your technology is going to spit out a decimal for you. Some calculators can handle it, but we're going to look at this, and first we're going to talk about just simplifying a basic number base example, constant base. And so this index, we already know what is the square root of 25. We want to be quick with that and be able to recognize, hey, that's 5 times 5, so it's actually going to just be 5 for an answer. But showing what's going on behind it will help you with the further examples. This is a square, this is really 5 squared, so now it's a positive base, same power as index. This is really 5 to the 2 over 2, or you can divide 2 into 2, goes in one time, so you just get 1 5 taken out, and there's nothing left. So the square root of 25 is just 5. And so by that definition of what a positive square root is, what's the positive square root of 25? It's 5. And so that's what we're looking at. Now, example number 2, same thing. It's a nice perfect square. I'm going to throw a variable in it, but that's okay. This is the same thing as saying the square root of 6 squared x squared. Sure, you could break these up. We could use that rule. And we know, and you don't have to do this, you can leave it all underneath one root symbol, but you can break this up to square root of 6 squared times square root of x squared is really what you could actually say. You don't have to, you can think of them all underneath one. Square root wipe out, you end up getting 6, the square root of 6 squared is 6, square root of x squared is x. Now, I'm also going to tell you that your book is actually going to give this answer. But I'm actually going to, with directions, say that assume all variables are non-negative or all variables are positive, so you don't have to worry about the absolute value thing. So when it comes to testing, I won't force you to do that when it's even index, even power, the same. You don't have to write it that way. So anyways, you'll see some homework examples that do that. Now, what if I run into something like this? Man, these all worked out nice and perfect that I had no root symbol left. What if I have stuff left in the root? That's the simplified, exact simplified radical form. The number 75 is not a perfect square number, so you're going to have stuff left underneath that root, so you have to leave it there to be exact. So when I do this, I'm going to try and think of the largest perfect square factor of 75. That is 25 times 3. And then this is x to the, I always leave my variables just with the same power on it. I know what the square root of 25 is, it's 5. I'm going to pull that out right away. Now, you could go one step further and say this. This is really the square root of 5 squared times 3, x to the 8, y to the 5th. You don't have to do that, because if you recognize that, you know it's 5, it comes out. This just shows that it's going to come out anyways. But that's okay if you want to do it that way. I know that 5 is going to come out. Now this index is a 2, right? We don't have to have it on there. We could add it if we wanted to. How do I know how many x's come out? What you can do is to shortcut this, instead of writing this as like x squared times x squared times x squared 4 times, you can just take this and divide 2 into your 8. It goes in an even, nice even 4 times, so I can take 4 x's out, or x to the 4th. And so that's going to be gone because it's a nice even number. 2 goes into it, there's none left in the house. Do the same thing with the y's. 2 goes into 5 twice, but you're actually left with a y in the house, or inside the root symbol, because it was an odd number. And then your root, which is left, and you're going to have a 3 still in there, and you also have a y still left inside. And that is simplified radical form, exact simplified radical form answer. And so those get a little tricky. You want to practice those for sure. One of the more important things, you get that down, it's going to help you with a lot of these operations and different things. So now let's look at something like this, where I can use that property that says, we use the product property here to help us. On this one, I can use the quotient property and say, wait a minute, I'm stumped. I have a fraction inside of this. I'm gonna actually break it up into two cube root problems, a to the 14, b to the 4 over the cube root of 27. That helps to recognize 27, cube root 27 is actually 3, it's 3 to the third, but if you don't, I'll show you this right now. I'm just gonna write this. This is actually the cubed root of 3 cubed. So 3 comes out, and there's nothing left in the house, or nothing left inside the root symbol. And this one, same thing. You can just take your index, divide it into your exponent for your variable, and you'll end up with a to the 4th. It goes in 4 times. There's going to be 2 left over, a remainder of 2. It goes into the 4 1 time, and you have 1 left over. Make sure you don't forget your index of a 3. If you put just a square root, it's going to mean something different. And then I'm going to have a squared left in there and just 1b left in. And that's my final answer. So the nice thing about these kind of problems, just like any other problem in math, we're always asking for one answer so that we can all get to one same answer. So we're looking for the simplified, exact simplified radical form. And so that would be that with those type of problems.